When most people hear the word sugar, they think of candy, desserts, maybe weight gain, and if things get really bad, diabetes. But that is an unbelievably small picture. Sugar is not just something that tastes sweet for a few seconds and disappears. It becomes chemistry. It becomes pressure. It becomes inflammation. It becomes hormonal chaos. It becomes damaged blood vessels, exhausted organs, unstable energy, accelerated aging, and a biological environment where disease quietly becomes normal. And the strangest part is that most of this starts long before you ever get diagnosed with anything. Long before diabetes. Long before fatty liver disease. Long before kidney disease. Long before your doctor ever tells you that something is wrong. That is the part nobody teaches in school. They tell you sugar causes cavities. They tell you maybe it causes weight gain. But they do not explain what sugar actually does once it enters the human body. They do not explain why one sweet drink can trigger a chain reaction that affects your brain, your liver, your pancreas, your kidneys, your blood vessels, your fat cells, your skin, and even the way your cells produce energy. So today, we are going to walk through the full map. Not the diet version, not the fitness influencer version, the biological version. This is sugar versus the human body. And once you see the full mechanism, you will understand why the damage is so much deeper than most people realize. To understand the damage, you first need to understand what sugar actually is. Because the word sugar sounds simple, but biologically it is not. When people say sugar, they are usually talking about sucrose, or table sugar. Sucrose is made of two smaller molecules joined together, glucose and fructose. That sounds like a tiny detail, but it changes everything. Glucose is the body's standard fuel. Your muscles can use it. Your brain can use it. Almost every cell in your body knows what to do with glucose. Fructose is different. Fructose is metabolized very differently, and most of the burden falls on the liver. That means every time you consume table sugar, high-fructose corn syrup, soft drinks, candy, pastries, sweet sauces, sweet coffee drinks, and most ultra-processed desserts, you are not just feeding your body. You are splitting a molecule into two very different metabolic stories. One part raises blood sugar and insulin. The other part places a heavy biochemical load on the liver and contributes to fat creation, uric acid production, and metabolic stress. And that is before we even get into how often people consume it. Because the real problem is not just one dessert, it is repetition. Sweetened cereal in the morning, sugar in coffee, fruit juice, energy drinks, sweet snacks, sugary sauces, dessert at night, healthy protein bars in between. By the time the average person finishes a normal modern day of eating, the body has often been hit over and over with waves of glucose and fructose it was never designed to handle at that frequency. And that is where the fight begins. The first system sugar collides with is the bloodstream and the hormonal network that controls it. When you eat sugar, especially in liquid form, it is absorbed quickly. Blood glucose rises fast. Your body sees that rise as a problem that must be controlled immediately. So the pancreas releases insulin. Insulin is not the enemy. It is a survival hormone. Its job is to move glucose out of the blood and into cells. But here is what most people never get taught. If you repeatedly spike blood sugar over and over, the body starts adapting to that environment. And the first adaptation is reduced sensitivity. Your cells stop responding to insulin as efficiently as they used to. This is called insulin resistance. Think of it like knocking on the same door too many times. At first, the door opens easily. But if you keep pounding on it all day, every day, eventually the person inside starts responding more slowly. That is insulin resistance. Now the pancreas has to release more insulin to get the same job done. And this is one of the most important hidden transitions in the body. Because once insulin stays elevated for long periods of time, the body is no longer just handling sugar. It is being pushed into a completely different hormonal state. A state where fat storage increases. A state where hunger regulation gets distorted. A state where the body becomes better at storing energy and worse at burning it. A state where inflammation starts becoming chronic. Most people think the problem starts when blood sugar becomes diabetic. No, the problem often starts years earlier, when insulin is already high, cells are already resistant, and the body is already compensating behind the scenes. That is one of the biggest things school never teaches. Disease often begins as compensation, not collapse. Collapse comes later. Now let's move to the brain. Because sugar does not just affect metabolism, it affects behavior. When sugar enters the system, it stimulates dopamine, the neurotransmitter heavily involved in reward, motivation, and reinforcement. That is why sugar feels good. That is why cravings feel real. That is why people do not just like sugar, they anticipate it. They think about it. They use it to regulate stress, boredom, sadness, and fatigue. The brain begins to learn that sugar is a fast reward signal, a quick chemical shortcut, and the more often that shortcut is used, the more the brain starts wiring around it. This matters because the modern food environment is not built around hunger anymore. It is built around hyperpalatability. Food scientists know exactly how to combine sugar, salt, fat, and texture to create products that override normal satiety signals. So now you are not just fighting appetite. You are fighting a reward system that has been trained to expect fast dopamine from engineered food. And there is another problem. Rapid sugar spikes are often followed by rapid crashes. That means the brain can swing from stimulation to fatigue very quickly. People call this low energy. People call it brain fog. People call it irritability. But underneath that, what is often happening is unstable glucose regulation. The brain is one of the most energy-demanding organs in the body. It loves stability. Sugar creates volatility. And once volatility becomes your normal baseline, concentration drops, mood becomes less stable, cravings intensify, and the body starts asking for the very thing that helped create the problem. This is how the loop tightens. Sugar gives reward. Reward builds habit. Habit creates instability. Instability creates more cravings. And the brain gets trapped inside a cycle it mistakes for comfort. Now we hit one of the most important organs in this entire story, the liver. Because while glucose can be used throughout the body, fructose is handled primarily by the liver. And when fructose arrives in large amounts, the liver has a problem. It cannot just let that energy float around forever. So it starts converting it. One of the major pathways involved here is called de novo lipogenesis. That means the creation of new fat. In other words, the liver can literally turn excess sugar into fat. This completely shatters the idea that only dietary fat makes you fat. You can drink something with almost no fat in it at all, and your liver can still manufacture fat from the sugar load. When this happens repeatedly, fat begins to accumulate inside liver tissue. This is how people develop non-alcoholic fatty liver disease. And what makes this so dangerous is how silent it is. You do not feel your liver getting fatter. You do not feel inflammation building inside it. You do not feel the exact moment your liver shifts from energy processing to fat storage. But the consequences spread everywhere, because once the liver becomes insulin resistant, blood sugar control gets worse. Triglycerides rise. Inflammatory signaling increases. The body's metabolic flexibility starts collapsing. The liver is supposed to be a controlled chemical processing center. Too much sugar turns it into an overloaded factory that cannot export the damage fast enough. This is why someone can look relatively normal on the outside and still be building a severely damaged liver on the inside. No alcohol. No obvious symptoms. Just years of sugar, processed food, insulin overload, and biochemical traffic that never stops. Now, let's talk about the pancreas. Because every time blood sugar rises, the pancreas has to respond. And if sugar intake becomes chronic, the pancreas is forced into constant labor. At first, it compensates beautifully. That is why early metabolic disease hides so well. The pancreas simply releases more insulin. More and more and more. Until one day, it cannot keep up the same way anymore. The beta cells begin to strain. The signaling becomes less efficient. The body that once handled sugar easily now needs a larger hormonal response for the same amount of food. This is one of the most tragic parts of the whole system. The pancreas is trying to save you. It is trying to keep blood sugar normal. It is trying to prevent glucose from remaining in the bloodstream where it can damage tissues. But in doing that, it can slowly work itself toward exhaustion. So when people say type 2 diabetes came out of nowhere, biologically, that is rarely true. It usually came out of years of compensation, years of elevated insulin, years of insulin resistance, years of pancreatic overwork. The diagnosis is not the beginning. It is the moment the compensation is no longer enough to hide the problem. Now we move to the kidneys. This is where many people completely underestimate sugar. Most people think kidney damage comes from salt, dehydration, or just getting older. But sugar can be devastating to kidney tissue, especially over time. When blood sugar stays elevated and metabolic dysfunction progresses, the kidneys are forced into a state called hyperfiltration. That means the tiny filtering units inside the kidneys are pushed to filter blood at abnormally high pressure. At first, that may sound efficient, but it is not. It is stress. Imagine revving an engine too hard for too long. It works for a while. Then parts begin to wear down. That is hyperfiltration. And there is another layer. Fructose metabolism can increase uric acid and oxidative stress, which contributes to vascular dysfunction and inflammatory pressure inside the kidney environment. Over time, high glucose, high insulin, inflammation, and abnormal pressure start damaging the filtration barrier itself. Proteins that should stay in the blood begin leaking into the urine. Scar tissue begins forming. Functional filters begin disappearing. And the terrifying part is that kidney disease can stay silent for years. You do not feel a nephron dying. You do not feel the moment healthy filtration tissue becomes scarred. By the time standard symptoms appear, a lot of damage may already be done. So again, the lesson nobody teaches is this. Sugar is not just a calorie issue. It is a filtration issue, a pressure issue, an oxidative stress issue, a long-term organ survival issue. Now we need to talk about the blood vessels. Because if the bloodstream keeps carrying excess glucose, eventually glucose starts doing what reactive molecules do. It starts sticking to things. This process is called glycation. Glycation happens when sugar molecules bind to proteins and other structures they were never supposed to bind to. That creates compounds called advanced glycation end products, often shortened to AGEs. And these compounds are bad news. They stiffen tissues. They damage structural proteins. They increase oxidative stress. They contribute to inflammation. And they accelerate aging inside the vascular system. Your blood vessels are lined with a delicate layer called the endothelium. This lining helps regulate blood flow, clotting, pressure, and vascular health. But repeated sugar spikes, insulin resistance, oxidative stress, and glycation can injure that lining. Once endothelial function starts declining, the cardiovascular system becomes more vulnerable. Plaque formation becomes more likely. Blood pressure regulation becomes worse. Circulation becomes less efficient. This is one reason why sugar is not just about diabetes. It is about the entire vascular map of the body. The eyes depend on blood vessels. The brain depends on blood vessels. The heart depends on blood vessels. The kidneys depend on blood vessels. Damage the vascular system, and you do not damage one organ. You damage the delivery network that keeps all organs alive. Now let's talk about body fat. Because sugar does not just increase total calories, it changes the hormonal environment in a way that makes fat storage easier and fat burning harder. When insulin stays elevated, the body is pushed toward storage. And one of the most dangerous places to store excess energy is not just under the skin, it is around the organs. This is visceral fat. Visceral fat is metabolically active. It is not passive tissue. It releases inflammatory signals. It worsens insulin resistance. It changes hormonal function. It increases the risk of cardiovascular disease and metabolic syndrome. So, when someone gains abdominal fat in a high-sugar environment, that is not just a cosmetic issue. It is a sign that the internal metabolic climate is changing. The body is moving into a more inflamed, more insulin-resistant, more disease-prone state. This is why two people can weigh the same, but one has far worse metabolic health. It is not just body weight. It is where the energy is going, how the hormones are behaving, and what kind of tissue environment is being created. Sugar helps create that environment, especially when it is combined with low activity, poor sleep, and constant processed food exposure. There is one more layer most people never connect to sugar: aging. Not just disease. Aging. Remember glycation? That same process that damages blood vessels also affects collagen and elastin, the proteins that keep skin firm and flexible. When sugar binds to these proteins, they become stiffer and more fragile. That means less elasticity, more sagging, more dullness, more structural aging. So when people say sugar makes them look older, that is not just internet fear. There is a biological mechanism behind it. The same chemistry that harms the inside of the body can also show up on the outside. And that should tell you something important. If sugar is aging tissues you can see, imagine what it is doing to tissues you cannot. Now here is the good news. The body is incredibly adaptive. When you reduce added sugar, especially liquid sugar and ultra-processed sugar sources, several things begin to change. Blood glucose becomes more stable. Insulin demand starts falling. The liver gets relief from constant fructose overload. De novo lipogenesis begins slowing down. Stored glycogen and water start shifting. Cravings begin changing as dopamine signaling starts normalizing. Inflammatory pressure begins dropping. The kidneys are no longer forced into the same degree of metabolic stress. The vascular system gets fewer glucose spikes to deal with. The body does not heal overnight, but it does start moving in a different direction. And that is the key. Every high-sugar meal pushes physiology one way. Every reduction in sugar pushes it another way. You are not just changing calories. You are changing pressure, hormones, fuel use, oxidative stress, fat creation, inflammatory tone. That is why quitting or reducing sugar often feels bigger than people expect. Because the change is not happening in one place, it is happening everywhere. So what were you never taught in school? You were never taught that sugar is not merely sweet. It is instructive. It tells the body what hormonal state to enter. It tells the liver whether to burn or store. It tells the pancreas how hard to work. It tells the brain what to crave. It tells the kidneys how much pressure to tolerate. It tells the blood vessels what kind of chemical environment they have to survive in. And when that instruction is repeated enough times, the body begins adapting in ways that look normal right up until the damage becomes impossible to ignore. That is why sugar is not just a food topic. It is a full-body biology topic. And once you understand that, you stop seeing sugar as a harmless treat with a few extra calories attached. You start seeing it as a signal, A signal with consequences. Now that we have mapped the whole battlefield, the next step is obvious. The liver, the kidneys, the brain, the pancreas, the skin, the blood vessels, because each one deserves its own full breakdown. And once you see those individual mechanisms in detail, the full picture becomes impossible to unsee.